Welcome back. In this video, we will be discussing the mole and Avogadro's number. In previous videos, we established a standard for determining the masses for all elemental isotopes and calculated the average atomic mass of each element based on the percent abundance of its stable isotopes. We can use these average atomic masses to determine how many atoms of any particular element exist within a given sample. Unfortunately, typical samples of matter contain overwhelmingly large numbers of atoms. Scientists have devised a unit of measure to represent the amount of a substance. This unit is called the mole. The mole is defined as the amount of a chemical substance that contains as many representative particles, atoms, molecules, ions, whatever, as there are atoms in exactly 12 grams of a sample of carbon-12. Approximate values for the number of atoms in exactly 12 grams of carbon-12 were first calculated in 1827. Since then, scientific techniques have been able to more accurately determine that the value of a mole is 6.022137 times 10 to the 23. For our purpose in general chemistry, we will truncate this value to 6.022 times 10 to the 23. This value is generally referred to as Avogadro's number in honor of Amedeo Avogadro and symbolized using capital N with a subscript capital A. Avogadro's number is so large that it's nearly impossible to conceptualize. However, the mass of atoms and molecules are so tiny that we need this enormous number. This is why scientists refer to the number of atoms, molecules, ions, etc. in a sample using the mole unit. Remember, the mole was defined as the number of carbon-12 atoms in a 12-gram sample. Remember also that the isotopic mass of carbon-12 is exactly 12 AMU. Since all isotopic masses are based off of this standard, we can further define the mole such that a sample of a pure element with a mass equal to its average atomic mass is 1 mole of that element's atoms. In other words, a 12.01 gram sample of carbon consisting of carbon-12 and carbon-13 contains 1 mole of carbon atoms. This can be done using the average atomic masses for all of the elements. 1 mole of iron will have a mass of 55.85 grams. We can now refer to the average atomic masses of all elements in units of grams per mole. Please note that the abbreviation for mole is MOL. Now that we have average atomic masses of all elements in units of grams per mole, we can begin to use the term molar mass to refer to these same values. For example, the molar mass of tin is 118.7 grams per mole. You will usually see molar mass symbolized as 2 capital M's. We can use the molar masses of individual elements to determine the molar mass of molecules and ionic compounds. Let's use water as our example. We know the molecular formula for water is H2O. Every molecule contains 2 hydrogen atoms and 1 oxygen atom. The molar mass of hydrogen is 1.008 grams per mole. And the molar mass of oxygen is 16.00 grams per mole. Using our formula, we can multiply the number of moles of hydrogen and the number of moles of oxygen by their respective molar masses, and then sum them together to determine the overall molar mass of water. Notice that we are using the addition rule for sig figs and can only keep 2 places after the decimal in our answer. This type of calculation can be done to determine the molar mass of any molecule or ionic compound as long as we can determine the chemical formula. For example, what is the molar mass of copper 2 nitrate? We know from the video on ionic nomenclature that the formula for copper 2 nitrate is Cu, parentheses for our nitrate, a polyatomic ion, NO3, and then a subscript 2, because our copper is a 2+ transition metal ion. The formula contains 1 copper, 2 nitrogens, and 6 oxygens. In order to determine the compound's molar mass, we need to add the molar masses of each of these elements using these ratios. Copper has a molar mass of 63.55 grams per mole. We have 1 in our formula. Nitrogen has a molar mass of 14.01 grams per mole times 2 from our formula. And oxygen, again, has a molar mass of 16.00 grams per mole times 6 of them in our formula. When we sum all of these together, we find the molar mass of our copper 2 nitrate is 187.57 grams per mole.